Let's do some problems on the projectile. Question number 1. A water fountain on the ground sprinkles water all around it. If the speed of the water coming out of the fountain is V, the total area around the fountain that get wet is. Suppose this is the fountain at it can give out the water at a speed of say given it is V. It can take water droplets can take the projectile path which is parabolic and hits the ground at some distance which is called the range. We have to find the maximum area, that means total area around the fountain that get wet. So total area, that means we have to find the maximum area. For this maximum area, if R is the range from this point, from the original point or originating point, that means area will be pi r square and R will be R max at angle equal to 45 degree. If this angle is 45 degree, then R will be maximum. And this R, we know the formula, range is u square sine 2 theta by g. And if theta is 45, then sine theta is 90, sine 90 is 1. That means range is u square by g. It means if water is coming out with velocity v, which is the initial velocity, we can say area will be r is v square by g. This is the r and its square. It means our answer will be pi v raised to the power 4 by g square. This is the area which is wet by the fountain. Question number 2. A shell is fired from the fixed artillery gun with an initial speed u. This is the initial speed. Such that it hits the target on the ground at a distance r from it. If t1 and t2 are the values of the time taken by it to hit the target in two possible ways. As we have already mentioned that range will be equal for two complementary angles, that is theta and 90 minus theta. Question says a shell is fired from say originating point O at an angle say theta with speed u and it get the range r. R is equal to which by the formula u square sine 2 theta by g. Same range we achieve with angle complementary angle, that is 90 minus theta. R will be also equal if angle is 2 into 90 minus theta by g. Same range for angle theta and 90 minus theta, 90 degree minus theta. These are the complementary angles. For complementary angles, range remains same. So as per question, our originating point and the target are same. So it means range is same. So there are the two ways to strike this target. Either it is fired at an angle of theta or at an angle of 90 minus theta. If T1 and T2 are the velocities of the time taken by it to hit the target in two possible, they then show that T1 and T2 equal to 2R by G. So what is T? T is the flight time and flight time is 2U sine theta by G. This is the formula of time of flight. So T1 will be for first case, it is 2U sine theta by g when it is projected at an angle of theta, and t2 will be 2u sine, now angle is 90 minus theta. If projectile is projected at 90 minus theta initial angle, then time of flight is t2 by g. As per question, we have to find the t1 and t2. So t1 into t2, it is equal to 2u sine theta by g into 2u sine 90 degree minus theta by g. Common term can be combined, that is 4u square by g square, then sine theta, and sine 90 minus theta, it means it is cos theta from trigonometry. Sine theta, cos theta, and 2 sine theta cos theta, it can be written as sine 2 theta. So it is 2u square sine 2 theta by g square. And from the formula of the range, that r equal to u square sine 2 theta by g, we can write it as 2 into u square sine square 2 theta, and one of the g is taken out. It will be r, 2r by, and remaining is g. That is our desired value, and it is solved. This is the answer. Okay, now we move to the question number third. Two particles are projected from the same point with the same speed u such that they have the same range. As per the above question, as we have already done, range is if object is projected at u square with the initial velocity u, it will be u square sine 2 theta by g. And this range will be same for the complementary angle, that is theta and 90 minus theta, 90 degree minus theta. For these two angles, we have same range. And range is u square sine 2 theta by g. But different maximum heights h1 and h2, and show that r2 equal to 16 h1 into h2. So in first case, maximum height is, formula for height is u square sine square theta by g. So in first case, h1 equal to, projected with the speed u square sine square, and first angle is theta, then it is writing sine square theta by g. Similarly, we can write h2 is equal to u square sine square. Now theta is replaced by 90 minus theta. It is another angle, that is complementary angle, for which again we have the same range, oblique g. And sine 90 minus theta is cos theta, so we can write it as u square cos square theta by g. We have to find h1 into h2. So h1 into h2 equal to u square sine square theta by g into u square cos square theta by g. And we have to write it as in terms of range. So it is equal to u square by g into sine theta cos theta whole square. We write u square by g sine theta cos theta whole square. It is equal to, because sine theta cos theta, we have to write it into the form of sine 2 theta. That's why we multiply and divide by 2. We get u square by 2g into 2 sine theta cos theta, that means sine 2 theta whole square. It is equal to, now we have to write in the form of range. Range is u square sine 2 theta by g, that is the r. That means it is r by 2 whole square. Mistake is there. Okay. This is u square sine square theta by 2g, and this is 2g. So we will get this 2g, 2g, and it is 2g square, and it is 4g square. That means it is r square by 4. It is equal to r square by 16. So this is h1 h2 equal to r square by 16. So this is our final answer. So we have proved it. Next question is question number 4. The trajectory of a projectile near the surface of Earth is given as, this is square. Trajectory is given as y equal to 2x minus 9x square. If it were launched at an angle of theta 0, so initial angle is theta 0 and velocity is v0, initial velocity. Then find, this is v0. Then find, we have to find this initial angle and this initial velocity as per question, and given g equal to 10 meter per second square. We have given the equation of trajectory y equal to 2x minus 9x square. It is a parabolic and graph is this like this, thrown with velocity v0 at an angle of theta 0. We have to find this v0 and theta 0 with help of the trajectory equation. For that, we have to differentiate it dy by dx, and it will give 2 minus 18x. Case 1. First we put dy by dx at x equal to 0. So this will give the slope of this trajectory at point this. This is the x equal to 0. At x equal to 0, we put x equal to 0, we get 2. So this is equal to 10 theta 0. This implies that theta 0 is equal to 10 inverse 2. This is the initial angle of projection. Similarly, to find the initial velocity, this is the v0 and this horizontal component is v0 cos theta 0. And at highest point, the component remains same. Horizontal remains same because there is no acceleration in horizontal direction and velocity becomes 0 in vertical direction. So only velocity at the highest point is v0 cos theta 0 and it is along the horizontal direction. That means it is the slope on the curve at the highest position, and highest position is achieved at x equal to r by 2, or we can say h equal to capital H, or we can say t equal to capital T by 2. So at these values we have slope on the curve is horizontal direction, that is 0. So that means we have to find the 0, and for that we can find the value of x. So dy by dx equal to 0 implies that 2 minus 18x equal to 0. This implies that x equal to 1 by 9. That means at x equal to 1 by 9, which is the half of the range, r by 2 equal to 1 by 9, and it is r equal to 2 by 9. And what is the r? R is initial velocity is v0. So u square, that is v0 square, sine 2 theta 0 by g, that is equal to 2 by 9. So it is, we have to find v0. So v0 square equal to 2 into, and g is given in the free question 10 by 9 into 1 by sine 2 theta 0. And now we can find the sine 2 theta 0 as, it is equal to 20 by 9 into 1 by 2 sine theta 0 cos theta 0. We have already find the tan theta 0. So it is theta 0 and tan theta 0 is 2, and tan theta 0 is 2 means perpendicular oblique base. So hypotenuse is 5 using the Pythagoras theorem. That means it will be 20 by 9 into 1 by 2 into sine theta is perpendicular oblique hypotenuse into cos theta is base oblique hypotenuse. That means we get 20 into 5 by 9 into 4. Cancel out 5, 4 will cancel out, that is 25 by 9. It means it is the value of V naught square, and V naught will be equal to 5 by 3 meter per second. This is the answer.